to local variable, and this local variable, we can name it local sprint state. The good things about local variable, it is only there inside the local space. So when it gets outside the local space, it disappears. It only lives inside this function. Therefore, we use a local variable here to get the client and server logic done. We need to check here and type in networking switch has authority. Basically, when the server is running, then we get in this authority, then is the server executing. And when the client is calling that function, then the remote part here is executed. We just want to get the remote part. What does the client do? He just calls the server function server toggle sprint. And here we need the local variable, local sprint state, just drag and drop it into the state. And yeah, that's for the client part. Compile and save. We'll explain it a little bit. The client is pressing the shift key, and based on pressing, it will be true, or releasing, it will be false. Then it goes to this function, and with switch has authority, the client will be on the remote part and will be server toggle sprint. And the server toggle sprint will be then executed on the server part, also the fsprint switch, and it will go here with authority because the server has authority, and the game logic for the server will be upstairs on the authority part, but on the remote part, it is a logic for the client. So then keep that in mind. When we are client and sending it just to the server and saying, server, we have a new state. And after that, we can just get as a client to update the local information. Just type in branch. And based on the branch, we can get our local variables. The local variables, just open it up, local sprint state. We can get it into the condition. And based on the local sprint state, we can branch the behavior on the client side. All right. So basically, when the player is pressing the key, then it goes to true. He is sprinting. And when he is releasing the key, then it will be here false. And so we can accelerate or increase the speed based on the behavior and the press button. When we look the class, the files, we have also the character movement here. And the character movement, we see that the max walk speed is about 500 centimeters a second. And the sprinting can be like 900. So we can define two variables. Just click on the plus. Jogging speed. It will be from type float. Then compile and save. After compiling, we can set a standard value. It will be 500. And then we need another variable, variables plus. These two variables are normal variables, not not the local ones. So is it shared variable from the client, BB hero chapter. The next one will be sprinting speed, also float, and we have to compile. After compiling, we can set the standard value. In my case, it could be 900. So just compile again. And what we do here, when it's true, then we are sprinting. We just can drag and drop the character movement. So the character movement component, just drag and drop it here. And after that, we can set the max walk speed. Just get this here and type down set max walk speed. So set max walk speed. In case of true, we are pressing the button, set max walk speed, and it will be the sprinting speed. So drag and drop the sprinting speed, which we set to 900. So in case true, we will be sprinting here. And in case false, we just want to set the max walk speed back to 500. So set max walk speed. Set max walk speed. Connect with false. And after connecting with false, we can just drag and drop the jogging speed, which is predefined in our case to 500. Compile and save. Because we are inside a function, fprint switch, we also have to get a return node. Just connect the dot. Type in return, add return node, and connect both states or both cases to the return node. That's for the client side. Our character movement will be adjusted when we press and hold the shift key. We will be oscillating or make the sprinting with 900 centimeter seconds. And when we are releasing the shift key, then we are just jogging again with up to 500 meter seconds. So that's the part for the client. We can just comment it with C. line sprint speed logic. Right. And that is for the client side. When the switch has authority, then we are on the server side. And basically, we want the same as on the client side. Just copy the code without the return mode, because we want to do something more. With Ctrl D, you can copy it. It was when the server is running with authority, the server side, that we want to get also the information done. It's players. Later on, we want to extend the server part. So here is no return node yet. We just can test it out, how it will work. Just compile and save. Press run. So when we are running around and press the shift, then we are faster. And when we release the shift, we are not so fast. So pressing shift, we go faster. And releasing the shift, we are not so fast again. It's working now fine for me. I hope it is working for you too. Just in case, if you want to debug something, I want you to show something quick. When you go to event graph and just want to debug some value, then you can go into the event begin play, just right click, event tick, and every tick event, it will be executed. And we want something like usually print string. It is a development only, and we can just get here our character movement. And then get max walk speed. And just plug in it. So we can see what is the movement. Is it changing or not? In case for debugging. And when we are playing now, I just get selected viewport and want to play in the selected viewport. So you see I have 500. When I press shift, then the value is 900. And 500 again. Also get the information for the pawn. Get player pawn. Transformation, get velocity. Mod vector length. That should be the value for our speed. So when we play now in the viewport, we see 0 because we are not moving. When we are moving, we see the 500. When we are printing with shift, then we see 900. So it's working now. when I release the case shift, in my case, I'm sprinting. So my releasing is not working properly. Maybe you too. Sometimes it's nice to debugging. It have some volume on the screen. So in my case, the started is working and the cancel is not working. You can just plug it with control pressed. So we have to be on completed when the boolean gets to false, and the function sprint switch have to fire the completion. So on started, we will start sprinting, and on completing, we are done. So compile and save. Now when I am running, I'm at 500. I'm pressing shift and I'm at 900. I'm releasing shift and again I'm at 500 and slower now. Now it's working just fine. And just in case, if you are debugging, you may get some information with event tick and the print. And here in our case, we want the speed in real time to check if our function is right. So that's okay for me. And the sprinting for the client side is working. basically on the animation bpterra. We have now a content browser layer, animation bpterra. We have the state machine where we added with right click the sprinting, the transition, the sprinting have the jog forward from the SS browser, which we are just drag and drop. The jog forward have the player rate of 2 to double the speed to look like sprinting. And when we go to the transition itself, then we can go to the sprinting from the jogging with several methods. I want to use an interface and interface based programming. It is likely better than casting and so on, because interfaces are not so much resource consumption. And interfaces could be used on every blueprint which implements this interface. So the blueprint information which can be get to other blueprints can be transferred using interfaces. We just can learn it by doing, and learning by doing approach. And I think afterwards you know what I mean by using interfaces in several blueprints to get the information between blueprints done. The interfaces you can find in every blueprint, for example, the BP hero chapter, the class defaults, in class settings, I think. Yeah, in the class settings, you can see there is some interfaces, and the implemented interfaces when a blueprint implements an interface and another blueprint also. So every blueprint which implements the same interface can communicate with each other. So interfaces are nice to communicate with blueprints. Get it as easy as possible. When some blueprint calls an interface and says, hey, I'm sprinting, then through interfaces, we can call other blueprints like the animation blueprint. It gets also the interface implemented and gets the trigger by getting information about a state, like sprinting. So the BP hero implements the same interface as the animation BP Terra, and so they can communicate through the interface. A basis communication, if you want. Therefore, we are going to the browser, and in the main folder, we create a new folder, right-click, new folder, name it interfaces, and inside folder interfaces, we will create our interfaces. First interfaces, which we want, are the interface for animation blueprints, then the interface for our characters, the hero character, and at base class, our game Souls game. So also the game Souls game need an interface to communicate. So this is 3 blueprints. Then we go to content browser, interfaces, just right click, blueprint interface, and rename it BP int animation BP Terra. Now we can open up the animation BP Terra to use this interface. You can go to class settings and implemented interfaces. Here we can edit. Just click add bb int animation bb So this class has implemented the bb int animation bb and each class which implements this interface can call the functions. When we open this interface, we can see on the right side is just getting some functions which are on each class which implement the interface available. So here you can see on the right side the functions which we can create. Every class, every blueprint which implements this interface have the functionality to call this interface class and talk to each other. What we now can do, instead of add custom event in some blueprints, we can call interface functions and get information. We send it between the blueprint classes within using the interfaces. I hope it makes sense. Basically, you can think about that the interfaces give the possibility to have shared functions within several blueprints. The other benefit by using interfaces, you don't have to use cast to some class. For example, something like cast to BB hero character, you don't have to use it. And every cast, you have to mention that it is consuming calculating power, it is consuming resources from the computer. And when you can avoid casting to some class, and this class maybe have a lot of subclasses which also loaded into the memory. And when we avoid casting and instead using interfaces, then our game will be run much smoother, was much better than just casting around. And keep that in mind. With interfaces, we can intercommunicate with other blueprints and we can avoid the casting to some classes, which are getting us in lower power consumption. The result is better performance of our game. Let's get started with the first interface function. Just get plus new function. Just name it sprint state. We have an input, a boolean, name it state, compile and save. And now we can use this sprint state function as an interface. Now we can go to our animation, blueprint there. And in the event graph, we can call the function of the interface. So we have implemented the bb_int animation bb_terra, and now we are able to call it. Just write down event sprint state, add event sprint state, it will call our interface function. Basically, we have some different approaches. We can work with interfaces and calling multicast, or we can also work with interfaces and variables which have an notify state. So it will notify all instances when the state changes. The next is we can go to state, right click, promote to variable, and just rename it. Is sprinting. Now we have the variable is sprinting when this event triggers. Now we can use the sprint in our animation graph. Just go to animation graph, our ground local motion movement, and from jogging to sprinting and from sprinting to jogging, we can say when the transition to sprinting is, then we can just get the variables is sprinting and drag and drop it here. So when it's true, then it will transition to the sprinting and back to the other transition from sprinting to jogging. Here we want to drag and drop is sprinting, get is sprinting, and just invert it. Much Boolean's function, not Boolean. So we invert the sprinting and connect it. When we are not sprinting, then we want just jogging. So when it's true, we are going from jogging to sprinting. When it's false, we go from sprinting to jogging. Compile and save. So when the interface function is called, we get here the transition from jogging to sprinting and from sprinting to jogging. In the event graph, we therefore have this interface function called, and when it triggers, then we set the sprinting variable based on what is giving in the state here. Now comes the interesting part, how we can use the interface within another blueprint class to send it to the animation blueprint, back to the BP hero character, in the BP hero character and in the event graph. We want to use it in the client and server section. Basically, when we are in the server here, and the server can notify or inform the others of the state. There are different approaches. One approach is to use multicast. The other approach is to use notify state of a variable. We use notify in this section. So when we go to the client sends the sprint switch and is remotely. So the client will sprint and send here server toggle sprint. Also, so he's sprinting and the server is notified by the client. And when the server turn comes with the same function, he's in the authority mode and will get here in this branch and set the according speed. We want a new variable, which is notify state. Just click on plus. Is sprinting. The variable is sprinting. It have to be a Boolean, just Boolean. And on replication, we want the replication with notify. So replication RepNotify. Compile and save. We can drag and drop the sprinting here. Get is sprinting. Here's our variable. This RepNotify means that this variable triggers a function or calls a function every time the value is changed, and this function is automatically add on the left side. You see the function on rep is sprinting. So this function is every time triggered when is sprinting have a changed state. Open it up, and every time the state is changed, we can just call here game logic. Now we can use it. The function fSprint switch. Basically, downstairs, when we are sprinting or not, we want to set this variable. Just drag and drop is sprinting, and set is sprinting. With Ctrl D, we can copy paste it downstairs. Connect just the upper logic with set with notify is sprinting true, because we are sprinting, and the other is false, because we are not sprinting anymore. So when the variable with set with notify is set, it will trigger the onRep is sprinting function. Which we can use for our logic. So based on it is changing, we have here our sprinting variable. Just drag and drop it here on the onRep is sprinting function. Get is sprinting. And here we need also a branch. Branch is sprinting. We'll get in the condition true or false. Now we want to call our interfaces. When here on this function we have true, then we want to set our animation blueprint is sprinting. This have to be then true on this place. And when we are sending the false, when false is sending, then the animation bugfix have to get here an false state in sprinting. Now we can get the information done with our mesh. The mesh have also the animation class and the animation blueprint Terra, which have the interface method for sprinting. So just drag and drop the mesh. And the mesh itself has also get anim instance. So we have to get the animation instance. After getting the animation instance, we can just call our functions. The usual way, which is not recommended, is to get here and cast to animation blueprint. paste the animation blueprint, and after sticking to the blueprint, get something like sprint state. So basically, this is one way to do it. But as I mentioned, the cas2 is not really efficient, and we can do it better. We can make usage of our interface. Just delete the cast on the side, and under class settings on the baby hero character, we can go to imports, interfaces, implemented interfaces, and add the interface, which is using our animation blueprint at the moment. Just plus. bb-int animation bb-terra. Compile and save. So this class also implements this interface. Instead of casting, we just can now go here to the return value and print sprint state. So we call bb-int animation bb-terra sprint state. It is a function inside our interface. We have the branch here. When it's true, we are getting just the sprint state within the interface call in direction to the animation instance from the mesh. And this is our animation blueprint, which is loaded in the mesh. And when it's false, we want to just get the state. Sprint state message. The false. Just connect it. That's it for the communications through interfaces. And because of BB Hero character and the animation BB Terra have implemented this interface, we can now just use it like that. So here we have the animation instance and just call the sprint state function there. And the sprint state function will usually fire this event sprint state and give the according sprinting information as a boolean. And when it's sprinting or not, it will be set here within a notify within the BB Hero adapter. And after this notify, it just calls it here. And after calling here, we have here a transition, even from jogging to sprinting or from sprinting to jogging, using interfaces. So interfaces is usually better than casting to a blueprint class, and the game should be run better, and the performance have to be better also. All right, before we trying it out, we basically can check it, double check it. So a client is sending the sprint switch by pressing shift, and is shift, and this is running, and speed up. Then it get calls. The call is getting here to the remote, because the client will always get it the remote, and the remote will be fired. Also, the server will be fired here with a state. So, and the client will get the notifies. On this state, we have to correct the code. A client should not set variables with notify. Just the server have to do it. So I will just Control X it to get this information up to the server state. When it comes to the server as authority, you have to notify the sprint state, Control V, and if it's true, then we are in the boolean true and changing the value. And when it's false, then we are changing the value to false. Just copy with Control D the return node. And get it to the client. So the client just only returns it. And the server will be setting the sprint state with notify. So the client is running faster than also triggers the server function here. This will fire up and then get itself a sprint state. It is a custom event which are run on server and reliable. And the sprint state which is given have to connect it here. We have just connects it. So we are sending with the server the sprint state. And when the server is getting called, in the switch has authority have always be called as a server. It sets a local sprint state. Then getting the information about sprinting, set sprinting with notify, and goes into the return mode. The set with notify will then fire up from each client. The onRep is sprinting, and basically onRep is sprinting is firing up the interface which lays on the blueprints BP hero character and the animation BP Terra. So with that behavior, the animation should be gets information through the interface sprint state. It calls in the event graph this event sprint state. Afterwards, it is setting is sprinting, and when it's set is sprinting is changing, then our ground local motion movement will be transit from jogging to sprinting and from sprinting to jogging. We can save all, file, save all, And to test it properly, we have to play number of players 2, standalone game, and here we can test how it looks when I'm moving around. So the player have to see me. We just have to open it right. We have number of players 2 and net mode, not standalone, because I started 2 standalone games. We can play as server or as client to test the behavior. We just play as a client and start it again. Now we have a server running and a client. And I'm running around. The client sees it. When I'm sprinting, the client and server sees the same. And when I'm running again, the client and server sees the same. So it just works for me. I hope you can see it on the video. Let's see the other side. When getting the other player, I'm also seeing the running around. And when I'm sprinting, also the other side sees the player sprinting or jogging. So everything works fine now. I hope it works for you as well. And that is our first multiplayer game logic with the sprinting and the notify state. Thanks for watching. This is one of the hardest lessons in the course. But if you followed step by step and know what we are doing, I think you are good to go to finish the complete course. Just keep in mind, when we are programming a multiplayer game, that we have clients, that is all the players playing, and the server, which is controlling and managing the variables and the notify states to notify all the clients when they are playing. So basically, we have something like client side and server side. And to call the server side, we are going to use switch has authority. So always just get the client logic done with the remote section. And within the remote section, we are calling before the logic starts for clients, also the server toggle sprint. So the server toggle sprint will be called and calls itself also the same function and gets into the upper state, the authority part here, because he's a server, and the server always prevent cheating or prevent game logic from being manipulated, and also prevent a notification for all players. So the same logic here, as on the client side, but the difference is that we have used a variable which have a notify state. So the variable is printing, is called its own function every time it changes the state with RepNotify. And this RepNotify gives us an onRep is printing function, which also, depending on the state, will be calling an interface. And this interface is implemented in each blueprint, which will be changing some information. In our case, we have the mesh here and the animation instance, and this animation instance have its own interface implemented for these functions. So we can call these functions just by using and configuring class settings in the caller blueprint with Vivid Animation Terra interface implemented, and the target blueprint, which is our animation instance, and the animation instance constructs an instance of animation Vivid Terra, and this have game logic for this function, basically setting based on the call the printing variable inside. And after setting this printing variable, we have our transition done from jogging to sprinting within the arrows here. So if it's sprinting true, then he can get the other animation done. And when it's not sprinting anymore, if it's not sprinting, then he transitions to jogging again. And that's for it. I hope you have an idea how to use interfaces, and see you in the next video.